So, like, this is the Oracle engine. So, no need to worry about this diagram, it's just a cool graphic. So, most people learn Oracle by memorizing commands, but very few understand what actually happens inside the Oracle database. So, what I'll be explaining in this video is the Oracle 19C technical architecture. This is the overall complex diagram. Don't worry, I won't be complicating this much. It will be a simplified version, but at the end of the video, you will be able to understand every component of this architecture and all the processes. So let's begin. Uh, Again, this is the Oracle Database 19C technical architecture, which is used in most of the Oracle ERP databases or the business databases. So let's begin. Think of Oracle as a powerful engine. SQL is just the ignition key. So Oracle server is a living system of two halves, or rather two parts. The first one is the Oracle instance. It's the actual thing, like the instance in object-oriented programming. What does it mean? Exactly that it means. It's kind of an object in a memory which occupies the space in memory, and this is the actual disk, or I will say the physical read, the Oracle database. Uh, so the Oracle instance lives in the memory. The Oracle database, it lives on the disk. So, like running engine, you could say, or this is the chassis and fuels, the physical collection of all the data files, and this is just the system or the kind of application engine that will help to manage and access the Oracle database. So, let's begin. This video would be focused on what are the processes, what are the commands, and how a single query in both the cases, read and write, works. Like whenever fetching a query or performing DML queries. So let's begin. The story begins with the startup, the reading engine blueprint. So you go on the terminal, you just go on the SQL startup. What does startup means? So it's the first process. When a database administrator issues a startup command, the first thing Oracle database does is it goes to the parameter file, it reads it, and it configures all the settings or all the configuration it requires to build the instance. So it consists of P file, it's a static text-based file, SP file, it's a dynamic binary file. The key difference is that the SP file could be modified while the database is running. So your database is a permanent. It contains data files, control files, and redo files. One of that is parameter file. It needs to be the P file needs to be configured at the earlier stage. Then there's the SP file. So moving ahead, there is the new mount phase. The instant comes into life in the memory. This is the exact point when all the things like the diagram I showed you, this SGA, PGA, all the things in the instance come to the life. So in this stage, we allocate the memory structures and out of which a large shared memory area is called the system global area, and then all the background processes are started. At this point, the instance is running, but it has no knowledge of the actual data files or the physical database files. It exists only in the memory. Inside the engine block, the system global area, the now moving ahead, this is the we'll be going through. Now moving ahead, this is inside the engine block, the system global area, this pod, SGA, it consists of database, buffer cache, and log buffer, and the shared pool. Large Java stream pool are very specific, so we'll not be covering much of them. Just go through the Google or something else or the notes provided in this video. Again, this part. So we'll be covering what is SGA right now. So like SGA consists of uh, SGA consists of shared pool, database buffer cache, redo log buffer. So SGA is a large read-write memory area shared by all users and processes. Imagine it's like a workshop where all the sections come to in place and do their things. Think of it as a main factory floor. It is memory components are shared pool. Shared pool consists of um, multiple things, but its main part is the analysis and planning department, caches executed, SQL code, execution plans, and data dictionary information. The analysis and planning part is done in the shared pool. Cache executes SQL code, execution plans, and data dictionary information. We'll be covering those two. Database Cafe, imagine it as a main workbench. Holds copies of actual data blocks recently ranged from the disk to speed of access. So whenever a data is pulled via query, rather than it maintains a cache, like rather than always going again to the database, we store that earlier fetched query in that database buffer cache, so we could reuse again, and it helps to basically speed up access. Read to log buffer. This uh, this is basically what it records everything, every single change made to the database before it's written to the data files. So it is important. Sorry, again, it's a circular buffer that records every single change made to the database before it's written permanent to the disk. Moving ahead, the SDA workshop, like moving ahead, the SDA workshop, deconstructing the shared pool. So whenever we do a select query, it goes in the SGA. SGA passes first of all the query. Now let's focus on the SGA workshop, deconstructing the shared pool. So the shared pool is involved in almost every database operation. Its goal is to maximize, reuse, and minimize repetitive work. So this is the shared pool. So whenever a query comes, it comes from the all the listening process, server process. We'll go over there later on. So but it goes to the shared pool first. Shared pool consists of a library cache, data dictionary, and result cache. So in library cache, it just checks the already existing execution plan. So if a query is already or the similar query is already run, it checks those things over here. Also, it passes all the queries. Like it goes through their grammar, if the syntax is correct or not. All those things happen over here. And then it moves to the data dictionary cache. Even if the query is already happened or it's already in the cache, it just go to the data dictionary to check whether the underlying query has its contents or not, like whatever it has requested, the tables or the exact files do we have in the we have in the database or not. It just checks that. It is also called the row cache, and in the result cache, it would be helping to fetch it out. So data dictionary caches recently used metadata such as user privileges. It also checks privileges, table definitions, and file names. This avoids constant slow queries against the underlying data dictionary tables on disk. So this is a simple diagram. This is what does SGA do. It selects whenever a query runs a select query, it goes. This is the this part, library cache part. So planning library cache, no. If it's no, it builds a new execution plan and it's called hard pass. It's slow and expensive. If yes, it's called a soft pass, fast and efficient. So there is basically two types of passing, hard pass and soft pass. So whenever a query comes, if it already is in the cache, then it gets those understanding from the library cache that we know that this query comes from the previous. Then it quickly checks all the privileges and all the table definitions. If we do have that, then it goes to the data buffer cache and it retrieves those information and return to the user. This is in this whenever it retrieves, we call this cache hit because we got the successful cache hit in the database buffer cache. This case is the ideal case and the most fastest case. It is called soft pass. But the opposite side, if we do not have that query or it's the new query, then we go to the library cache again. It generates a new plan. It again checks in the database buffer cache. Do we have that? If it is not, then we go to the actual database in the data files. We'll also understand what are the following those things you see down there. Let's move on to the next slide. So the engine workforce or all the processes meet the background processes. So we are now let's talk about the engine workforce. So all the background processes. These mandatory processes start with the instance and perform essential maintenance and IO tasks. So this is the database writer, this is a checkpoint, this is a log writer, and there are other process monitors, PMON, SMON, COG checkpoint. So we'll go through all of this. So DBN periodically writes modified dirty data blocks from the database buffer cache to the physical data files on the disk. Just read this all things. I'll be explaining in a practical query. Now, mount stage. The instance knows about the physical disk. In the mount stage, the instance associates itself with the physical database by reading the control files. Control files contains essential information like the database name, the name and locations of all database files and redo log files, the current state and the checkpoint information needed for recovery. Without the control files, the RAM might not know about the disk. The instance knows where all the physical components are, but the data set itself is not accessible to the user. Why? Because there is another phase remaining. That is called the open phase. In this phase, the database is open to the instance and vice versa. So now let's understand through a query the journey of a select query. This is the read case. So whenever a query runs this particular query, this is a basic SQL query. It goes and will be going through all the processes. First of all, it's the parsing, that's soft pass and hard pass. If the query exists in the library cache, we use the existing plan. We use the existing plan. That's the fast pass or the soft pass. And we also do a quick check in the data dictionary cache for all that row definitions, table definitions, and privileges. And then we return that, and then we go to the database buffer cache. If the data exists, then it's a cache hit, and that's the soft case or the soft pass. And in the hard pass, it will go through library cache. No, not it's a new, so it's not already cached. So we create a new plan. Then we go again to the database buffer cache. We look out for the data over there. If it's not, then we go to the database, and that's the hard pass. It requires time and it requires a lot of memory. So it's the not ideal case. So that's the reason why this is so optimized for more read and write operations. So now let's understand through write operations or the DML commands. In the DML commands, whenever we are updating a thing, we update that thing in the database buffer cache. So what happens? So whenever we first of all we need to fetch like select where then change all those things we do now. So all this selecting the retrieving thing would be the same, but whenever we do the update, it will go here and it will write that block over here. That is called data. In this that block is called dirty block because so that is called dirty block. So the dirty block. So this okay. that is called dirty block. This is written in the log buffer also. This is redo log buffer. They have not named it properly. So this is redo log buffer. What this redo log buffer does is it records every information. So after writing the data, after writing the data into the dirty block, that dirty block needs to also write a log in the redo log buffer. So this is called a redo log buffer. What redo log buffer does is any update or any DML changes are recorded in this. So whenever we do a commit, then the log writer, this process writes that log in that permanent data into the data file into the data file. So after the commit statement only we will write it. If it not, then there is also thing called undo process which will undo the thing. Moving ahead, these are the data blocks, and there is the another thing called checkpoints which mentions all the um, it's kind of a log. Moving ahead, we will speak. Okay. So again, after writing the block into the dirty block, we write into the redo log buffer that is written by a log writer to the redo log file. Then there is the commit process. After the commit, only it will write to the redo log file, and whenever there is space or time remaining, then the database writer process will write into the data file. So log writer immediately writes read into the disk. The commit is confirmed only after the write is complete. The change is now permanent and recoverable. So now how data is organized from a logical concept into the physical files. So let's understand the hierarchy. To easily understand, we could have a simple remembering thing called BEST. So B stands for block, E stands for extend, S stands for segment, and T for table space. So the Oracle data block, it's the smallest unit. The size is basically 8 KB, contains headers and row data, actual physical data, extend a contiguous set of data blocks allocated to a segment. So like if a writing process needs more of the blocks, instead of having a single block always, we will just use an extend. Extend is like basically a bunch of blocks. Then like 128 blocks might be a extend. Then segment. An object that consumes space like table or index is called segment. And a table space, a logical container for database objects such as users, systems, the transactions. So this is the high level thing or high level segregation. So yeah, this is pretty much everything about the Oracle database. The Oracle achieves performance through memory caching and safety through redo logging. So all the online redo log files help in point-in time recovery. And how do they help? Because they have all the information like whenever those things were changed or whenever those things were updated. And all of the data is stored in the archive redo log files. This is main file that helps in recovery, backup and recovery. Also in the cases of disaster and recovery. So this is the important thing. Rest of this are basically understandable. So these are the listener processes. And this is user process and server process. You could understand it simply like that. This is program global area, shared global area, parameter file. Earlier I spoke about this. Basically, it consists of all the configurations we made about the instance. And this is password file. It consists of the schema passwords required to access this instances and database. Um, Oracle separates logical structure from physical structure. So it's pretty much everything. This helps in speed and recovery faster. So, yep.